Welcome to tonight's panel. I'm Dr. Cassandra Steer. I am at the Australian National University College of Law and a mission specialist with the Australian National University Institute for Space, InSpace. And I'm a founding member of the ANU Centre for Space Situational Awareness Research, or CESAR, which we will talk a little bit about tonight. I'd like to begin by acknowledging country, acknowledging the traditional custodians of the land on which we are hosting this virtual panel. So we all on this panel are in Canberra on Ngunnawal country, and I pay my respects to their elders past, present and emerging, and to the respect of all the traditional custodians of the lands wherever you may be, wherever you're joining us from. And I extend that respect to Aboriginal and Torres Strait Islander people who are joining us today. So we're here tonight to talk about space sustainability, space security and safety, and space junk. So we have more than 3,200 operational satellites orbiting Earth. And those satellites are things that we are dependent on for pretty much every aspect of our 21st century lives. So for TV broadcasting, for internet, for telecommunications, probably you're using satellites to watch this webinar right now or to watch it, the recording of it later. We use it for extremely important things like bushfire monitoring, climate tracking, weather prediction, GPS for navigation, and of course the military uses GPS. We use it for search and rescue and health services and so much more. We are thoroughly dependent in our daily lives on satellites. And that means we're dependent on the sustainability of the environment in which those satellites are orbiting. So on top of those 3,200 operational satellites, there's another approximately 3,000 dead satellites, or sometimes they're called zombie satellites, that have outlived their life. They are no longer functional. They are just drifting in orbit. And some of them may stay there for up to 100 years in orbit. And no one really knows how much space debris there is on top of these defunct satellites, but the estimate is there are about 1 million pieces of debris larger than 10 centimeters. So that might be remains of old satellites, it might be an old rocket stage from a launch, it might be something like an astronaut's glove. And then on top of that, we have an estimated probably more than 128 million pieces of very small debris, smaller than 1 centimeter, as small as a fleck of paint. And those smaller pieces of debris tend to be caused by collisions, sometimes between those larger pieces of debris. And most of those objects are fairly small, but when they're traveling at 7 kilometers per second in orbit, the velocity at which that they're traveling means that they are potentially lethal to the International Space Station. There was a time when something the size of a fleck of paint damaged the space station and for a while compromised the safety of the astronauts on the space station. And very importantly, all of this debris threatens the working satellites that we depend on. So the greatest challenge that we have is being able to accurately track these objects. How many of them are there? How large are they? What orbital trajectories are they on? Is there a risk of collision? And just to make things even more challenging, added to that is the amount of active space traffic that we already have is only growing, while the size of satellites is actually decreasing. That's what's making access to space cheaper, which is exciting for universities doing research. It's exciting for startups. It's exciting for new kinds of technologies like being able to provide internet to very remote areas. But when we have smaller and smaller objects and more of them, we have an enormous problem of space traffic management, and we have even greater risks of collision with the existing space debris. So currently about 100 satellites per year are being launched, but that's already starting to increase already in 2020. Probably you've heard in the news of companies like SpaceX that are launching constellations of satellites. So SpaceX wants to provide internet to very remote areas, or in fact to the entire globe. And it's doing so by launching packages of tens of 20s of satellites at a time. Its plan is to have a constellation of 40,000 satellites. And a recent estimate that I heard was that in 10 years' time, we may have 100,000 operational satellites on top of all of the debris that I just mentioned. So this is an enormous problem, and space traffic management issues are getting rapidly more and more complex, with even greater potential for debris creating collisions. And the more debris we have, the more risk there is of collisions. And very soon we have what is known as the Kessler Syndrome, which is that if we reach a critical mass of debris, it's just going to become exponential and completely unmanageable. One of the problems is how to dispose of satellites after their lifetime, and also cleaning up the existing debris that we have. So we've asked our co-founder, the co-founder of the Center for Space Situational Awareness Research, CESAR, Dr. Moriba Jah, to give a short video introduction. So his video was recorded in Texas, where he's based. He is a visiting professor here at the ANU, although because of COVID-19 travel restrictions, he hasn't been able to visit us in person. But he's a world-leading space environmentalist, and we're very glad to have him be part of the team. And so if I could ask our InSpace team to share the video by Moriba Jah.
Hi, my name is Moriba Jah, and I'm an associate professor in aerospace engineering and engineering mechanics at the University of Texas at Austin. And I'm also a visiting professor at the Australian National University's Research School for Aerospace, Mechanical, and Environmental Engineering within the College of Engineering and Computer Science. I'm also a mission specialist in ANU's Institute for Space, or InSpace, focus on space situational awareness. And so my role at ANU is to work with others in developing what we're calling CESAR, which is a Center for Space Situational Awareness Research. This is really a transdisciplinary research opportunity to combine science and policy to address some critical needs in space safety, security, and sustainability. Interesting topics in space safety might be things like trying to find ways to track things better, this human-made population of objects in space, this anthropogenic space object population, being able to do a better job with helping people avoid collisions in space. From the sustainability perspective, it's really looking at things like ecological sustainability, even taking note of what some of our indigenous people have done through traditional ecological knowledge. Tenets of this traditional ecological knowledge could help us do a better job with achieving sustainability in space. And then from a space security perspective, really understanding the different threats that might occur in that domain and how to monitor for these things. People are interested in everything from how do I avoid colliding to how do I monitor for behavior, how do I assess compliance with different space rules, policies, and regulations. And all of these things are topics that we're really interested in developing in CESAR. So part of the way that we intend to measure ourselves in what we're doing at CESAR is, one, how do we make the domain more transparent? In other words, how do I know what's up there? Who does it belong to? What could it do? The next thing is predictability. If I can predict what's going to happen 3 days from now, a week from now, I can help keep myself safe and others safe as well. And predictability isn't just about the astrodynamics, the motion of things in space just due to the natural environment, but there's a subset of objects that humans control. And so in any given scenario, how would any given two space actors or entities behave or react? What would they do in a given scenario? So there's a cultural competency that we need to apply to that. And then the last element is, can we develop a body of evidence that can be used for decision making, decision intelligence, and to hold people accountable for their behaviors in space. So I'm very excited in this Space Week 2020 to be a part of what ANU is doing with the rest of Australia to really deliver world-class capabilities in space situational awareness.
So that was Moriba Jah joining us from Texas. So I guess the thing to point out is that space situational awareness is a term that is used quite often in the space sector, in the space community. And that's exactly what it means, what Moriba was talking about, and the picture that I painted for you at the beginning about the enormous challenges we have of space traffic management and dealing with debris. It is situational awareness of our space environment, and it's really starting to think about our space environment as part of our natural environment, and an environment we are highly dependent on. So wouldn't it be amazing if we could, it sounds a little bit like science fiction to talk about traffic management in space and to talk about the threats that debris make to our daily lives. Wouldn't it be great if we could come up with a science fiction solution for that and just have robots cleaning up all of that debris in space, selectively catching the debris and the defunct satellites while leaving the operational ones in place? We don't actually have that technology yet. There are companies and universities who are working on various active debris removal technologies. So there are some who basically have fishing nets. There are some industry partnering with university who've come up with and successfully tested using essentially a harpoon to shoot out and capture a piece of debris and then reel it back in. But there are a couple of issues that prevent this from developing as fast as it needs to. One is that there's no really demonstrated business model for cleaning up the debris of others. Think about if there's a business model for cleaning up our oceans. It's hard to make a profit for that, so it's hard to get sufficient investment into it. The other is that all of those debris removal technologies, anything that is able to capture a satellite or even be able to service a satellite while it's in orbit to lengthen its life, that potentially could be repurposed for less benign purposes. So essentially you have something that could be repurposed as a space weapon or being able to capture an adversary satellite or interfere with it. And so there's also hesitation on the part of governments to really invest in these kind of technologies. Instead, what we're left with is the scenario that here on Earth, thoroughly dependent on space activities and space technologies, and still really having to learn to think about space as part of our natural environment. And we don't have a clear understanding of just how much debris is up there and just how many objects are in orbit at any given time, much less the ability of being able to remove it. And that is where our amazing panel of experts that we have before us tonight come in, because they are going to be talking about how their work plans to make space safer, more secure, and more sustainable. And all of them are involved in some way with ANU's CESAR, and they're all really at the very leading edge of this kind of technology and research in Australia. So I'll be asking the panel some questions, and then we will move over to a question and answer session. So please feel free to start sending your questions in now by using the Q&A button at the bottom of your Zoom screen. And we will make plenty of time towards the end of this panel to pose those questions to our panelists. And so I'd like to introduce you to our amazing panelists. Joining us are ANU In-Space Mission Specialist, Dr. Doris Grosso. She is an optical instrument scientist with the ANU Research School of Astronomy and Astrophysics, and with the Advanced Instrumentation and Technology Centre on Mount Stromlo. She's a passionate advocate for the sustainability of the space environment, and she's been developing optic systems for the characterization, analysis, and management of space debris. So she's going to tell us a bit about what all of that means. Then we have Professor Céline Dorcheville, who is also at the Research School of Astronomy and Astrophysics at the ANU, also part of the AITC on Mount Stromlo. And she's the AITC Laser Guide Star Adaptive Optics Group Manager. And she's going to tell us a little bit about what adaptive optics do and why that's important for space situational awareness. She's also an ANU Translational Fellow. So she's aiming to transfer her semiconductor guide star laser research into the commercial world. Extremely important that the deep and cutting edge research that we do at the ANU also reaches the commercial world. And finally joining us we have Dr. Noelia Martinez, who is a postdoctoral researcher in the Adaptive Optics Group at the Research School of Astronomy and Astrophysics, and also part of the AITC on Mount Stromlo. She was awarded her PhD in 2019. The topic was Adaptive Optics for Free Space Optical Communications, and generation of laser guide stars, which she's going to tell us about shortly. So as you can tell by the names of our panelists, we have a multilingual international panel. And I also feel compelled to point out that it is an all-female panel, and that was not by design. That is simply just that we have a truly international and diverse range of experts at the ANU. So we have a diversity of viewpoints brought from international expertise, and this panel is going to give you a glimpse into that expertise across the world, which we're very lucky to house at the ANU. And I welcome viewers who are joining us interstate and also internationally, and if you're watching this recording at a later time. So I'm going to start our discussion with mission specialist, Dr. Doris Grosso. So we have had a couple of events, Doris, in recent history, in the last 10 and 20 years, which have created an enormous amount of space debris. So in 2007, we had perhaps the most disruptive event when China destroyed one of its own satellites in what is read to be a test of an anti-satellite weapon. The US and Russia have also tested similar weapons, although creating smaller amounts of debris. And then there was also an accidental collision in 2009 between a defunct Russian satellite and an active US satellite. But I think the overwhelming feeling amongst most people is that the reason most of the general public isn't really aware of the space debris problem is because we've been lucky enough that there haven't been catastrophic effects in terms of what happens on Earth. I wonder if you could talk a little bit about why it is that space debris really is a problem and about your work in characterizing space debris.
Yeah, thanks, Cassandra. Vielen Dank für die Einleitung. Thank you very much for your introduction into the topic. Yeah, so as you say, space debris is really not too much of an apparent issue for all of us here down on Earth. As a matter of fact, you know, researchers have come up with the number of 1 in, I think, 300 trillion times likely to be hit by a piece of space debris down here on Earth. So it's, you know, be more likely to die in a car accident for sure, and even being struck by lightning multiple times in a row before you get hit by space debris. So that's why it's kind of out of our sight. And as you pointed out, there were already events in space, however, where debris collided. And I would encourage people to watch the news tomorrow at Australian time at around 11 a.m. tomorrow, or UTC time, I think it's 1 a.m. tonight. There are 2 big objects, both defunct, a big satellite and a big rocket body, who are set out to potentially collide with each other. And the collision chance is actually about 10%. And that is huge for something in space. So normally the ISS maneuvers out of harm's way when we have a 1 in 10,000 chance, which is like 0.001%. And now we have a 10% chance of collision. So we are on the lookout for thousands of more pieces of debris potentially being created tonight. And the nature of this environment is that things don't necessarily happen all the time because there is a lot of space, but when they do happen, things are catastrophic and fatal for things in space, basically. So that's sort of a bit of the environment that we're talking about that we can't see directly. Now, what about my work? As we heard by Mariba as well, we want to get the environment more transparent and more predictable, and also create a body of evidence so that we are able to identify what has been hit and what hit the object potentially. And my work actually plays into all of these 3 items directly. So I'm developing optic systems to characterize and identify those space debris objects, or satellites for that matter, in their shape and also their rotational attitude, we call it, their rotational, how fast they spin basically, and also what they're made out of. And currently actually with conventional telescopes, we look at the night sky and we see dots and we track the dots, and then we know where things are. And we can predict where they're going to be, but we don't really know what they are. Things have been cataloged and tracked continuously, so we kind of are pretty sure what they are, but there's a lot of pieces out there that we're actually not too sure what they are. So if we actually can see them better and resolve them and see what shape they are, we might be able to at least see, okay, it's a big piece, a small piece, and things like that. On top of that, if we know the shape of the object itself, we can actually make the prediction better, because up there in space, although everybody says, you know, there's a vacuum, there's no atmosphere, that's actually not true. There is actually some atmosphere left in the low Earth orbit environment, and different pieces of debris react differently. So slight chances in their size create a difference in where they're going to be in orbit. And that way, they might collide or might not collide with other things. So we need to know more about where they're going to be. So by looking at more, looking better at how they look like, we will know better where they're going to be. Now,
so I just want to ask, so that can help to predict, so you can actually then, that information can be used to alert satellite operators, for instance, there's a risk of collision, you need to maneuver. Like, that's the way the information can be used?
Yeah, so I mean, this already happens today, but the alerts that come out, there can be hundreds of them in a year. And the satellite operators, they basically currently operate on the amount of probability that they get, or is it like, you know, is it like a 10% hit is like, we have to move. But normally they, you know, they don't move all the time, because if they move, then they lose precious fuel, and that will shorten the lifetime of the satellite. So the idea is, if we can predict better or more accurately and more precisely where things are going to be, then the, you know, false alarm rate of collisions will actually also go down, and satellite operators are informed better of whether they want to move their satellite or not. So that's the idea behind it. And as I mentioned before, we are aiming to do that with our optical systems that we are building. It's actually an optical system that sits behind the telescope on ground. And we're using a technique called adaptive optics to do that, to increase the resolution, basically. And it's actually a technique that's been used extensively in astronomy. And I'm very happy that our panelists here on the panel are the experts in that field, so they might be able to shed more light on the technology itself.
That's great. Thank you, Doris. So it's extremely important improving the information that we have about these pieces of debris. So Céline Dorgeville, can I ask you to tell us a little bit more about adaptive optics, so the history of it is that, if I understand it, it's been used for astronomy, and it's now being applied as a technology to help in space debris identification. Can you tell us a bit more about that?
Yes. Bonsoir tout le monde, ou bonjour, en fonction de où vous trouvez sur la planète. Good evening, everyone. I'm very happy to be part of this panel. Thank you, Doris, for introducing the concept of adaptive optics, so I can maybe explain a little bit more about how this works. But first, I want to relate what it's for. So I'm going to ask the question to our audience, whether they've sometimes wondered why stars twinkle. When you look at the night sky, you see the stars twinkle. But if you watch a sci-fi movie and it's taking place in space, you would see dots of light that don't move or don't twinkle at all. So the difference is that we're observing the stars from the ground here, and we have the atmosphere standing in the way. So when the light from, say, a star comes down through the atmosphere, it gets distorted. And that is this distortion that adaptive optics is aiming to correct for. So what we want to do is be able to use large ground-based telescopes, because it's much easier to work on Earth than it is to work in space, where you can't send large pieces of optics and mechanics. So we want to work with these ground-based telescopes, but we need to correct for the atmosphere. So adaptive optics does that. As the name indicates, we use adaptive optical components, and the main component in that system is usually a deformable mirror. So you can think of it as a surface that you can move in real time. So the adaptive optics is able to measure the distortion that is imposed on the light on its way down towards the telescope. And the deformable mirror changes its shape so that when you bounce the light of that surface, you can correct for the distortions in real time. So this is quite a fantastic technique that's been proposed a long time ago. Well, not so long, but 1953, it was first proposed by a researcher called Horace Babcock. And at the time, it was a great idea, but the technology wasn't there to implement it. So over the years, astronomers have started to think about it again, and then develop some systems to put on their telescopes to look at stars. And instead of getting blobs of light at the focal plane of their telescope, they now get really sharp images. And when you get sharp images, you can see more details of the object. So if you're imaging, say, a planet, then you'll be able to see details of the planet instead of just being a round fuzzy blob. So this is a technique that's been really useful for astronomy, and that's a technique that we can use in the context of imaging satellites or debris, space debris. So it's the same idea. If you want to take a picture of those satellites from the ground, you also have to look at the light that's coming from the satellite. It's usually not the satellite's sending light itself. It's the reflection from the sun rays of the satellite that we can see. But the light is going through the atmosphere as well, and we also need to compensate for it so we can do better images with more details. So that technique is quite powerful, and actually you may have heard last week that the Nobel Prize in Physics was awarded to 3 astronomers who've been working on black holes. One was a theoreticist who predicted what will happen with black holes, and the other 2 were observational astronomers. And these astronomers, they use adaptive optics in their daily work to study the supermassive black hole at the center of our galaxy. So it's kind of convenient that this announcement was made last week when we were going to talk about this topic today.
So again, it's really exciting technology that already for the purposes of astronomy, but for the purposes of being able to track and identify space debris, so adapting this technology for a new purpose. So then I'd like to ask Dr. Noelia Martinez-Rey to tell us about your studies of adaptive optics and how much of that is built on space data, and what does that mean for SSA? So if you could tell us a little bit about the laser guide star and the way that you're using it for space situational awareness.
So, hi everyone. Buenas noches, Australia. Good to be in Australia. Thank you for being here today with us. So I'm going to talk a little bit about adaptive optics with laser-guided stars. So as Selina already introduced, adaptive optics measure and correct for the atmospheric turbulence. So in order to correct for that turbulence, the sensor measuring these atmospheric distortions needs a reference on the sky. So in astronomy, and at the beginning of the adaptive optics history, we usually use natural guided stars, so normal stars on the sky, that we can look at them and sense the atmospheric turbulence that the star's light is going to suffer when it's traveling downwards to the Earth. But there are not enough bright stars on the sky, even if it looks impossible. There are not enough. So we need to find a mechanism to correct for the atmospheric turbulence when there are no available stars on the sky. And that's actually the case of space situational awareness, because if we want to image a satellite that is moving across the sky, we don't have a natural star following that satellite. So we need something else. And what we use are called laser-guided stars. And basically my background image is a picture of guided star lasers in the Keck Observatory in Hawaii. And the way they work is the following. So we launch a laser from the ground towards the sky, and we create an artificial light source on the sky for us to sense, to measure this turbulence. There are basically 2 types of laser-guided stars. The oldest one is called Rayleigh laser-guided star, and it's usually produced with a green laser. So we launch this laser upwards to the atmosphere, and the dust particles that are suspended in the atmosphere will reflect back that laser light. and it's going to create this artificial light source on the sky for us to use in our adaptive optics system. The second type is what you see in this image, is the sodium laser guided star. It's produced by an orange laser, is the wavelength of the sodium. And the way it works is the following. So we launch this laser from the ground, again, upwards, until we hit the sodium layer, a layer of sodium atoms above the Earth's surface at approximately 90 kilometers height. And this laser light is going to excite the atoms in this layer, and these atoms will glow, producing this artificial light, this artificial laser-guided star that we are going to use in our adaptive optics system. So in SSA, in space situational awareness, our adaptive optics systems need to have laser-guided stars. So it's actually a crucial point, because otherwise we cannot measure the atmospheric turbulence in the same optimum way, because there is no natural star following the satellite. For less optimum correction, we could use the light of the satellite itself, so the sun reflecting on the satellite, so that light, we could use it as a reference source, but the correction would not be as good as with a laser-guided star.
It's really fascinating work. So I briefly just want to remind our audience that you can post your questions using the Q&A button at any time. We encourage you to do so. I have a quick question for you, Noelia, because you said it's at around 90 kilometers that the laser-guided star is operating. Is that to do with the atmosphere? And I'm asking that because I'm not a scientist, I'm a space lawyer. And one of the biggest questions, unanswered questions in space law is, where does airspace end and space begin, outer space begin? And usually we say it's around 100 kilometers, but there's no legal definition. So why 90 kilometers for the laser-guided star?
So 90 kilometers is the layer where the sodium atoms are deposited based on meteorites around the Earth. So this layer is composed not only by sodium atoms, but also by other components, other atoms of other elements. But sodium is the element with the bigger abundance. So that's the one that we want to excite, because we need to generate a bright source there.
Mm-hmm. It's really fascinating to me, and it's also really wonderful to hear about the fact that lasers are actually really important for space, but not in the way that people think of in terms of Star Wars. So the piece I want to add to this whole conversation is, as I pointed out, you all are extremely very skilled scientists doing really important work for our ability to be able to track objects in space, debris in space, basically every human-made object that is in space. And so as a space lawyer, I don't do the actual work in space, but my concern with space situational awareness is on the law and policy side. So we don't have any international law that really restricts this number of launches going into space, or that requires a country or a company to clean up that space debris. And that's one of our problems. What we have is the 1967 Outer Space Treaty, which is kind of our constitution for activities in space. It has some really important principles which all actors in space adhere to. So it is a successful treaty in that sense. And one of the articles of that treaty, Article 6, says that states, so countries, are responsible for the activities that go on in space under their jurisdiction, whether they are governmental or non-governmental, so commercial activities. And that states are therefore required to authorize and continually supervise those activities. So what that means is that every time an object is launched into space, it is done so under the jurisdiction of a country, and that country will have a licensing process in place. So in the US, they have a very complex licensing process. In Australia, we have our own space agency as of 2018, and anyone who wants to have a launching technology or have an object launched into space or operate a satellite in space has to have a permit or a license from the space agency. And that's because Australia needs to know what is being launched into space from Australia or by Australian companies, even if they're being launched in other countries, so that we can keep a track of all of this. There's another treaty called the Registration Convention, which obliges countries to register in a national registry every single thing that gets launched. And also to register that with the UN Office of Outer Space Affairs, which is the depository for an international registry. And so that the intention of that is that it can help us also know on paper at least what has been launched, what has been declared. The problem is adherence to that. So the majority of launches do get registered. I think the UN itself has reported between an 80 and 90% compliance rate, but that's based on what they know. So there might be even more launches. So the launch itself will be registered. It's a very difficult thing to hide, but what is actually being launched, what is on that payload, how many satellites, particularly now that satellites are getting smaller and smaller, what orbital trajectory they're on, what frequencies they're using to communicate their information, how long they intend to be operational. So at what point in time are they likely to become space debris? And are there any plans to deorbit those satellites at the end of their life? So one of the problems is that it takes a long time for that registration to take place. Sometimes it can be 4 years after a launch. So there's an enormous gap of knowledge in terms of what's on paper. Sometimes also those satellites may change hands. They may have been sold on, or the company that originally launched it may have gone bankrupt, or it may have been privatized if it were originally a governmental satellite. So just tracking the factual reality of who owns those satellites and what they're doing is a challenge. Similar to the challenge of tracking the physical objects that are in space. And so we have these treaties. What we do have is a bit of a push recently for non-binding guidelines. Treaties are very difficult things to negotiate. They take a lot of time, they take a lot of political will. And so there seems to be more of a push to have an agreement on essentially codes of conduct. Last year in 2019, the UN Committee on Peaceful Uses of Outer Space, which is the committee tasked with being responsible for all of these kinds of activities, and originally tasked with drafting up the treaties that we do have, the original 5 space treaties that we have that were drafted during the Cold War. They have been unsuccessful in drafting any new treaties since the Cold War. There's just no desire to do so. But what they did do last year was adopt 21 guidelines on the long-term sustainability of outer space activities. So sustainability really is an international concern. It's a global concern because of the ways that we are all dependent on space, because everybody knows that there's this massive increase already and in the next few years in terms of launches of active satellites. And there's an enormous concern for ensuring that companies, because it really is much more commercial entities than it is states launching satellites today, ensuring that those companies are obliged to have an end-of-life plan, a space debris mitigation plan. Will they reserve some of that very, very precious fuel that Doris spoke about to deorbit a satellite, or potentially to put it send it further out into what is an unusable satellite? I have a concern about that latter plan, because really what you're doing is just posting the problem for later. And I really think the best way to think about it is the way that we're littering our oceans is what we're doing to our natural space and environment and to these very valuable orbits. And so that is the kind of legal and policy challenge that goes with the very difficult technical challenge of tracing what's happening in space. So we're going to move shortly to questions from our virtual audience. So please do keep posting those questions in the Q&A. Just before we do, I have one more question that I want to ask of all 3 of you, which is, what is the one thing that you want Australians to know about this problem? Doris, let's go to you first.
Yeah, I think I'm going to start with like an inspirational thing. So obviously we painted doomsday now for the past 40 minutes. And I would like to think about, like, people need to be aware of this, of course. Space debris is an important issue, but I would like for everybody to think about, if we actually manage this problem properly, we are not, avoiding destruction. We actually open the door and unleash an environment that we can use to get better data, higher definition, more information, access to more remote areas. So it's actually like the gateway to, advanced technology, rather than sort of all be pessimistic about in 20 years we're not going to have internet anymore.
It's good to keep us positive as well. Like, what it requires is to be thinking about how exciting it is to have those kind of technologies. How can we ensure that we keep the environment safe, secure, and sustainable so that we can keep benefiting from it? Céline.
Well, in my case, I'd like to speak of the sustainability aspects of the problem, because I think it's just terrible that as a species, humans have trashed their own planet, and they're now moving into trashing the environment around the planet. And there's a risk that we continue, and keep doing that. As a researcher and a science fiction fan, I strongly believe that the human species will eventually go, somewhere else than planet Earth, either because they need to and they don't have a choice, or because they want to. And the only way we can do that is if we are cautious with the way we manage our space environment. So I think it's very important that even if it's not affecting people's lives right now, they are aware that we're starting to pollute space pretty badly. And eventually this will affect us or next generations, and it will matter to everybody. So I would like people to be good citizens and understand pollution in space just as much as they understand pollution on Earth, and be vocal about it.
Yeah, so the long-term sustainability is really key, isn't it? And that's what the UN guidelines really highlight. It's about long-term sustainability. It's about intergenerational responsibility, which brings me back to Moriba's point about traditional ecological knowledge and the knowledge we can benefit from Indigenous communities who've known how to manage environments for intergenerational reasons for many thousands of years. Noelia, what would you like, one thing you'd like all Australians to know about this?
Yes, I would like to add to what Doris and Celine just said, that everyone loves the space, right? The space is this cool thing that everyone loves it. So, but maybe not everyone is aware of like how essential space is for everyone's life. And before it's too late, right? Because we trash the planet, and I think we realize quite late on the way, right, that we have done it. So before it's late, let's start behaving properly right now.
Yeah, thank you. Thank all of you for pointing us to what's really important. So there's some questions here from our audience, from anonymous attendee. Would the debris eventually turn into rings around the Earth? I guess if I read that question properly, when we look up at Saturn and it has rings around it, is that what we have around us with space debris now, Doris or Celine?
Well, I may offer some quick answer. First, if you look at some of that information on the internet, you probably come across these movies that show clouds of debris orbiting the Earth, and you see multiple layers of them. So you see a cloud close to the Earth, which is all the objects that are orbiting at low Earth orbit, which is about 800 to 1,000 kilometers. And then you see another ring that's further away, and it is a ring already of satellites that we call the Geostationary Satellites. They are those satellites that, if you look at them from the ground, they appear like they are fixed in our sky. That's because they are rotating at exactly the same speed we are. And these satellites are very important for telecommunications and everything that is related to how we communicate from one point of Earth to another through space. So there is already a ring, and this is just happening already, and the rest of the debris is a bit more chaotic and looks like a cloud. So it's like you're going to have to peel out that cloud of debris in order to access the Earth.
So thank you for that clarification. Zachary Hook has asked a question that follows on from that. So if we have these rings around the Earth of debris and also of active satellites, will that affect anything about the Earth? Will that affect temperature, for instance, or anything of the physics of the Earth, do you think?
Well, I think that would be quite a catastrophic scenario if we get to that point. Right now, we shouldn't worry about this kind of thing, and hopefully we can act way earlier than getting in that space.
So some of these questions might be inspired by science fiction, but I think that's sometimes a really good place to start, particularly when people are really starting to think about these issues for the first time. Ash Watson has asked a question about the Artemis Accords. They have been signed this week. It was announced just last night for us that Australia signed an accord with the US. We're one of 7 countries that has done so. And the Artemis Accords are really set up to support the Artemis program to return humans to the moon, the first woman and the next man to return to the moon within the next 4 years, and also to think long-term about mining resources in space. And there is a section in the Artemis Accords which refers to orbital debris. And Ash's question is, will this meaningfully impact your work or the issue? So the thing I would say about that, that part of the Artemis Accord is, and there are some really key principles in the Artemis Accords which I think there is global agreement on. The need for transparency, the need for sharing of information. So if through this amazing work that's being done by Doris and Noelia and Celine, for instance, if that information can be shared internationally, that benefits everyone. So greater transparency, and also the need to consider the impact of orbital debris. So whether that agreement will meaningfully impact this work, I think what it does is it demonstrates that there is very much an international concern for it. There are parts of the Artemis Accords which are contentious to do with mining of natural resources in space and safety zones. And so what we're seeing with the Artemis Accords is a potential development in interpreting what international law says around these issues. And so when there's international agreement on an issue, that's a really good thing. It's a really good political sign that everyone agrees that orbital debris has to be an absolute priority of our activities in space. So there is a question here somewhere about there's a benefit. Bronwyn Collins has asked this question. It seems like there's a benefit to the commercial companies to be managing their space debris, or otherwise they themselves will end up having their valuable satellites damaged at some point. Do you know if there are any companies at least making noises about managing this risk, or is it still early days? Are they still focused on short-term profit? Doris, do you have an answer to that?
So, I mean, historically, actually, they didn't have an incentive to do anything about it because there was enough space in space. So they didn't actually have to worry about it. They could just dispose of them and they would just stay in orbit and they wouldn't have to think about them, and they just put a new satellite up in space. But now that it's becoming a problem, there is actually a couple of sustainability efforts here and there. So for the biggest, obviously most popular example is actually SpaceX. If you think about it, with their sort of sustainable rockets, the fact that the rockets are coming back down again and can be reused, they're actually not staying, all the rocket stages don't stay in orbit like they do necessarily, because they're flying them back down. That's already helping getting the big rocket pieces out of space, basically. So they are actually actively trying to diminish some space debris. But then at the same time, SpaceX also wants to launch, mega constellations of satellites into space. So they are actually also thinking about having their own satellite protection system on board that's communicating with other satellites and stuff like that. The problem always is that the satellites that are already defunct or already in space, on the debris in space, they cannot communicate with new things that come up because they don't have those devices on board. So it's always harder to manage those satellites. And for those satellites that are out there, because it's becoming a problem now, there is now a few startup companies that are commercial companies who offer solutions to deorbit satellites and basically catch them. And also space agencies like the Japanese Space Agency, JAXA, and ESA in Europe, they are actually funding a lot of projects for this active debris removal, as we call it. So going up there with a satellite, grabbing something and bringing it back down.
So maybe with the support of government investment, the business model might become more attractive for active debris removal. There's a question here from an anonymous attendee for Noelia. How is the tracking data provided to the outside world? So it's great to have it for research purposes, but is it being provided to the outside world? Can this be provided in real time? And are there ideas on how this data can be made available to lawmakers and decision makers?
So right now there are few catalogs created by different agencies available that are publicly available. It's not everything is not in the catalog, of course, because there might be some assets related to defense of certain countries that are not available in the catalog for the public. Actually, one of the CESAR's goal is to create a global network of sensors to see what is up there and to improve our knowledge of the amount of objects in space. So in general, one could check, for instance, Astrograph is a website, it's a database, huge database created by Muribaja. And anyone can go and check in the website the amount of objects that are there. And you could see, for instance, the debris objects related to the collisions that Doris and Cassandra talked about before, the ones happening in 2009 and the one happening in 2007. So this Chinese anti-satellite weapon test and the collision between Iridium and Cosmos. So you could go there on the website and check it. It's really interesting. About making things available in real time, that's a bit more tricky, I think. We still need to develop the techniques to see beyond what we can see right now. So with these adaptive optics techniques and the system, we have a system at Mount Stromlo called adaptive optics for tracking and pushing. This is a system, an adaptive optics system for maneuvering small pieces of debris. This system is being developed together with AOI, which is adaptive optics for imaging and tracking of satellites. So with those two systems, we aim to improve our knowledge of the space environment and ultimately to slightly move out of the way pieces of debris that could collide with other pieces of debris or with bigger bodies in space.
That's perfect. That actually answers another question that Laurie Brown had asked, that he'd actually heard that lasers could nudge the debris so that it eventually deorbits. So that's what you're suggesting. So again, lasers being used for something just entirely different when most people talk about lasers in space. Now it's being used to clean up debris. Dina Tsavula asked the question, overall, do you think that better navigation techniques suffice? Or do we need to figure out a way to clean up the debris within the next 10 to 20 years? I mean, I think that goes to, we have the problem of the existing debris. And then on top of that, we have the problem of, many, many more active satellites and new debris. So can improving our technologies suffice, or do we also need to improve our ability to clean up that debris? Doris, Celine, sorry.
I could a piece of answer. I think the problem is not just knowing where objects are, it's the ability to move them, because as Doris explained, every time you want to move a satellite outside of its current orbit, you have to use energy, and therefore you have to use fuel, and therefore you reduce the lifetime of the satellite. And so even if you know perfectly where it is and you know perfectly where the debris is and that they might collide, you're going to have to move one of these two pieces so they don't collide. So if it's an active object, that's the easy thing. You use the fuel on board and move it away. If it's a debris and you can't maneuver it, then we can use what Noelia was talking about, maybe nudge it out of the way with a laser. But this is just a mitigation strategy. The real strategy is really to go up there and clean up space and not create more debris by being irresponsible in the way we send things to space.
Which is what those long-term sustainability guidelines are about. So it's up to countries to implement those. So there's the option of cleaning up, or the necessity to clean up debris. There's another question here by Greg Pierce. What are the options for satellite refueling, which would help to extend the life of a satellite? Doris?
Yeah, so the problem comes back to, obviously, the satellites that are already in space out there. They don't have the mechanisms and the devices, like they don't have a fuel tank that has a nozzle that you can fly up there and refuel the satellite, basically, because no one thought about it. that way. There is now startups that work on those things to keep like a satellite running, but like rule number one, you can't just go up there and refuel something because the device is not there. You can't just, it's just not possible mechanically and technically. And rule number two, at the moment, it's too expensive to actually do that because you have to have more fuel, like a payload, which means a big satellite that brings the fuel to the satellite in space, and that costs a lot of money. And at the moment, it's just cheaper to put a second satellite up in space that does the same work for it. And of course, on top of that, it's not only the fuel that runs out, the sensors wear off because there's obviously hard radiation there in space. So things break down in space, and basically you need to maintain the satellites a lot over time. So is actually the ISS being maintained constantly. So unless access to space becomes cheaper and cheaper, we can't really maintain things in space directly.
That is disheartening to hear, because I'm always quite enthused by the idea of on-orbit servicing. You know, it kind of comes down to reduce, reuse, and recycle. If we can extend the life of these satellites, maybe that would be better than launching more and more things into space. But if you say that the business model is not there, then there's little.
It will be possible at some point, but access to space needs to be really cheap for that.
Yeah.
I just wanted to add a really cool idea that's been proposed, and that some companies are already working on, to refuel satellites would actually be to shine a bright laser to them and recharge their batteries through their solar panels. That's
wow. Yeah.
use of lasers that people don't quite know about. Yeah, it's not happening yet, but it is going to happen, I think, in the near term.
There's the thing that strikes me, and again, I'm not a scientist and I never got excited by a science career, but it strikes me that there are so many different types of scientific knowledge that go into designing and launching and operating a satellite, and its solar panels and its fuel sources, and you know, there are a million different types of skill sets needed for moving forward into ensuring that space is sustainable. I think we have time for 2 more questions. So this one quickly from Duncan Blake: how precise could tracking be by space object laser tracking? Celine.
So right now, people are already using lasers to track objects with or without adaptive optics, and they can track systems, objects down to a centimeter or a few millimeters at best. With adaptive optics, you can also image larger objects. So we were talking about position before, just the tracking part, but now I'm talking about the imaging part. And if you're looking at an object that is orbiting, say, at 1,000 kilometers above the ground in low Earth orbit, with adaptive optics and a 1 meter or 2 meter telescope, you could see details that are on the order of a few tens of centimeters in extent. Now, if we're looking at objects that are at geostationary orbits, so now this is 36,000 kilometers away from us, it's pretty far. You can't image the object. You can't see, you know, details of the object. You will see it as a point, but we can very, very precisely know where that point is in space, and that matters a lot to geosatellite operators. And so we can hope to do that to within a couple of meters, which is pretty exceptional, I think. It hasn't been demonstrated yet, but we're working on it.
So this last question, I think that we have time for, that I'm going to ask each of you to answer, which is: what can the public do, audience members listening to this, or the public in general, to improve the situation now so that we're more aware of the problem of space debris? Doris.
I would say Saturdays for satellites instead of Friday for futures. Well, not instead, on top, you know. So if the public is aware and speaks up, they can basically support that satellite operators are more sustainable. But then I think, or they can not pressure, but like, you know, tell the government to put things in place so that the government regulates policies around it. But in the end, policies needs to be created. But if the public speaks up, like with demonstrations, or I don't know, you know, that's the way to kind of tell the politicians that they want things to be changed, basically.
Great,
Yeah,
thank you.
exactly.
Noelia, yeah?
I was going to add that society has a lot of power, like a lot of power. Everyone is aware that this is a problem, and this Kessler syndrome will happen at some point if we don't do anything about it. So it will have a lot of power in like big companies, in governments, agencies, and so on. So I think just raise awareness of this issue is already a really important thing to do. So go and tell everyone.
Tell them to watch the recording of this panel, because I really, the three of you have done an exceptional job of communicating quite complex things. Being a science communicator is a skill, and I think you've done an amazing job. Celine, what can the public do?
I was going to say as well that information is power. The fact that you're listening to this panel is already the first step. Know what's happening. And once you do, tell your friends, like Noelia said. And the next step is vote with your feet. When you vote for politicians, or when you buy stuff from companies, maybe get some information about whether they are engaged in that process and they have something good to do about it. And yeah, have a say in your future.
So I would add to that social media. I mean, just making these things an issue that is being talked about in social media is already something to bring it to greater awareness amongst the wider public, because as everyone has said so far, greater awareness really is the key. And for anyone who is, a school leaver, or perhaps in university, or even given COVID, thinking about pivoting a career, to just kind of dig in a little bit more to what kinds of careers are possible, what kind of skill sets and knowledge can contribute to it, because this is a burgeoning, the space sector is a burgeoning sector anyway. Space situational awareness and the many diverse transdisciplinary kinds of knowledge and skill sets that are needed to advance this is we need many different perspectives and ways of thinking, and there are many exciting career trajectories there as well. So that would be my addition to it. We have to bring it to a close. I really want to thank our three panelists: Doris Grosso, danke; Celine Dorgeville, merci beaucoup; Noelia Martinez-Rey, gracias. And I also want to thank the team behind the scenes who put this together, in particular Kathleen Sweetapple from InSpace, and Pam Larandas from Strategic Communications and Public Affairs, SCAPA at ANU. And thank you also. I'm sorry that there were some questions we were unable to answer, but we really appreciate you taking part and watching this panel. And we hope that you will go on and discuss this issue more and make more of it. Thank you.